This is the second video in a module on artificial intelligence. The first part of the video covers on the introduction to AI, while the second covers on the competencies of AI. There are many definitions available on AI, but here we refer to it as the simulation of human intelligence in machines, and these machines are programmed to think like humans and mimic their actions. The term AI may also be applied to machines that exhibit traits associated with human mind, such as perception, problem solving, learning, communication, and ability to reason. The term AI is not new, but because of its current emergence, now everyone needs to understand its possible impact, what it can and cannot do, determine when it is useful versus when its use should be questioned, and how to steer it for responsible and safe public good. The AI literacy consists of two parts. The first is the data literacy, which covers the ability to understand how AI collects, cleans, manipulates, and analyzes data, as well as the second part on algorithm literacy to understand how the AI algorithms find patterns and connections in the data, and these together can be useful for human-machine interaction. AI can be categorized according to its focus, its purpose, and its ability to act autonomously. All of these indicate the intelligence in its ability to think like a human, to think rationally, to act like a human, and to act rationally. For an AI to get its intelligence, it actually observes its environment and collect data by its observation, and it is able to then respond according to its level of autonomy and memory as it was designed. Let us now look further into how AI really able to get its intelligence. We will start by the classical AI approaches, which these approaches are based on symbolic representation and rules-based approach. For example, if you are familiar with expert systems, something that tells you about certain decision or some recommendation based on many facts and rules that is expressed by the expert, that is named by expert systems. However, this approach is laborious and it is very difficult to properly extract, identify, and organize these facts and rules. Furthermore, when there are new facts and rules that are available, reiterating and regenerating the rules is very cumbersome. Luckily, the more recent advancements of machine learning, which are one of the algorithms in AI, have able to learn from massive volumes of data, and this is also owing to the advancements of storage and computational technologies. So these machine learning approaches, they look and sift through a lot of data and generate rules automatically by the machine learning models instead of using purely humans to express the rules and facts. In this respect, the algorithms are said to be able to learn as opposed to being pre-programmed by a human. Luckily, the more recent advancements of machine learning, which are one of the algorithms in AI, have able to learn from massive. Let us now look at the current advancements of machine learning algorithms. So now we have two categories: standard machine learning algorithm or the traditional approaches against deep learning, which is the derivation from machine learning algorithms, which are based mainly on the neural network approaches. These artificial neural network algorithms are like the brain structure which allows the relationship within data to be extracted and to be connected. The deep learning is the subset of machine learning algorithm. Meanwhile, the machine learning is the subset of AI. Data analysis is one of the typical and very important functions of AI. Typically, AI relies on large datasets for training algorithms. So, here let us look at how the algorithms are being trained on the data. There are several steps. The first is to define the question. For example, to try to identify the risk of students dropout. To be able to go deeper and understand this relationship, we have to collect data, and the sources can be from the learning management system, can also be from the assessment records. After we gather this data, we clean the data using several operations such as selecting the data, extracting data that are useful to our question just now, to integrate this data from different sources, and also making sure that we transform it so that it is normalized. After that, we can use AI algorithm such as the machine learning approaches to model and find relationship within data. After that, we can use data visualization technique to express what we have learned. For example, the rules as well as the clusters. And this expression through visualization make people understand what is the relationship within the data. And from this pattern, we can use it to augment new possibilities and predict new possibilities in the future. Now, let us look at the possible applications of AI specifically in teaching and learning. For example, for instructional design improvements. Maybe you have heard that AI can be used to design and develop personalized learning experiences. Do you know that this is done using the prediction models development as well as the dashboard development? This is an example of a dashboard to let the instructor knows about students at risk, and from this information the instructor would be able to identify possible personalized learning pathways to cater to each of the students individual needs by sifting through the records as well as his engagement. This is an example of the output of a machine learning model based on decision tree algorithms. The decision tree algorithms can visualize and express the learned model called decision rules. These decision rules can be read to be able to identify possible outputs based on the past happenings. AI can benefit many more aspects of education. For example, in education management and delivery, to empower teachers and to enhance teaching, as well as in learning and assessment. The applications are typically developed by using machine learning. We will look after this at the algorithms that can be used to develop each of these applications. Here you could see even more tasks that can be completed by AI, and this is based on various algorithms. For example, to predict students that will visit LMS based on their provided historical and seasonal trends, to be able to perform some clickstream analysis on the university website, to search students who are with common interests, and to identify or calculate the probability of a student who will fail in the next 6 months. By knowing all of this in advance, the instructor as well as the administrator can take suitable actions. Just now, you have looked at the example of algorithms. Here, let us look at the categories of the algorithms according to its machine learning approach. Basically, machine learning approaches can be categorized into supervised, unsupervised, and reinforcement learning. The differences are typically based on how the model learn or being trained on the data. The supervised machine learning algorithm learn based on past data and labeled sequence, while the unsupervised learning algorithms learn based on unlabeled dataset. The reinforcement learning algorithms, on the other hand, learns based on rewards as it observes the interaction with the user. One can develop a machine learning based applications by using tools and programming languages such as Python, SAS, RapidMeter, and Microsoft Azure. In each of these tools, there are a lot of libraries and functions that can be used to train the machine learning algorithms, create dashboard, and connect as well as integrate the applications. Besides the competency to be able to identify suitable AI to be developed, the machine learning algorithms, the tools and applications, one of the most important competency is ethical considerations of AI. In this perspective, one should look at the potential bias in the AI because the coverage of the data that it is being trained concerns that AI could replace human jobs rather than augmenting intelligence of the human, possibility of privacy concerns, as well as the possibility or risk that AI may deceive or manipulate human as well as the environment. Finally, an educator should also have one more crucial competency related to AI, ability to collaborate and communicate relating to AI concerns. This regards the communication with stakeholders to ensure that the AI powered education solutions are effective and aligned with the educational goals, as well as going back to governance. Google chief decision scientists have once advised the leadership teams on the decision process, AI strategy, and building data driven organizations. Steps that can be taken for leadership and data science governance are identifying who is in charge, suitable use case, do some reality checks. Do you have the data from the team? And then analyze the business performance metrics wisely as well as set the key performance index. As a summary, AI competencies are very important for educators. So they know how to improve the student learning outcomes based on data driven insights. They can automate certain administrative tasks that is mundane or routine, enhance student assessment by identifying students who has gaps compared to their expectation, to develop the AI competencies in concepts, data analysis and management, instructional design, to know what AI tools and platforms to use, to know what are the ethical considerations, as well as to develop ability to collaborate and communicate using the AI insights.